Greetings. In the earlier part, number 1, we have studied some basic definitions and the special points we required while curve tracing. So let's start with the methods of curve tracing. The type 1, that is Cartesian curves. To trace the Cartesian curves, rule number 1 to 5 are required. So whenever we want to draw the curve or whenever we want to trace the curve, we will first apply rule number 1, then 2, 3, 4, 5 in the sequence. And while this writing the description rule number 1 to 5, we will be able to draw the rough sketch of the curve. So if you look at the mark distribution, if the problem is of 6 marks, then this 6 marks will be divided as, if you give the proper description of the curve, then you will get 4 marks to the description and 2 marks for the rough sketch. So only sketch is not important. If you just draw the curve, you will get only 2 marks. Rather, if your complete curve is correct, then only you will get 2 marks. Otherwise, you will get only 1 mark. So basically, if we are not able to draw the curve, but you are able to describe it, then also you will get 4 marks. That is out of 6, 4 marks. So more than 50% marks you will be able to achieve with the help of this description. So we'll start with the rule number 1, that is symmetry. So this rule will give us the nature of curve, whether it is symmetric. If it is symmetric, where it's symmetric. So there are different types of, rather different aspects of symmetry. First is symmetric about x-axis. If the equation of the curve contains all powers of y even, then the curve is symmetric about x-axis. अगर किसी भी इक्वेशन में y के जितने भी टर्म्स लाई कर रहे हैं, अगर सभी टर्म का पावर इवन है, तो such type of curve is called symmetric about x-axis. For example, y square equal to x. If you observe in this example, the power of y is 2, therefore this curve is symmetric about x-axis. Similarly, you can guess the second one, that is symmetric about y-axis. If the all powers of x are even, then it is symmetric about y-axis. For example, x square equal to y. There are some curves which are symmetric about both x and y-axis. So if all the powers of x and y are even throughout the equation, then such curve is symmetric about x and y-axis. For example, x square by a square plus y square by b square equal to 1. If you quickly revise, this is the equation of ellipse. Ellipse is symmetric about both x and y-axis. Next, symmetry in opposite quadrants. Suppose we replace x by minus x and y by minus y, and the curve remains unchanged, then this curve is symmetric about opposite quadrants. For example, y equal to x cube. So अगर हम x की जगह माइनस एक्स डालते हैं, y की जगह माइनस वाई डालते हैं, तो हमको मिलेगा माइनस वाई इक्वल टू माइनस टाइम्स एक्स क्यूब, दैट इज माइनस एक्स क्यूब. Minus minus signs get cancelled and we get y equal to x cube. Therefore, this curve remains unchanged. Therefore, curve is symmetric about opposite quadrants. Next, symmetric about line y equal to x. If in the equation of curves we replaced x by y and y by x, y और x को interchange करते हैं एक दूसरे के साथ, still the curve remains unchanged, then it is symmetric about line y equal to x. For example, xy equal to c square. अगर आप x की जगह y डालो, y की जगह x डालो, फिर भी आपको same curve मिल रहा है. Therefore this is symmetric about line y equal to x. Similarly, if we change x to minus y and y to minus x and the curve remains same, then it is symmetric about y equal to minus x. For example, xy equal to c square. Again, if you put x equal to minus y and y equal to minus x, minus minus becomes plus, the curve is same, therefore it is symmetric about line y equal to minus x. So this is rule number 1 with different 5 aspects of symmetry. One is symmetric about x-axis, another is y-axis, third one is both x-y axis, fourth one is in opposite quadrant, fifth one is about y equal to x, and last one y equal to minus x. Obviously, curve will satisfy any of this condition. Then rule number 2, first हम देखेंगे whether the curve is symmetric or not. अगर symmetric है तो कौन सा condition satisfy कर. Second, we will see the points of intersection. In this, we have different aspects. The first aspect is origin. First, we will check whether the curve passes through origin. If the curve satisfies 0, 0, then curve passes through origin. It is easy to understand. So, अगर curve origin से pass हो रहा है, then we are interested in finding the tangent at origin. So, the tangent at origin can be obtained by comparing the lowest degree term in the equation to 0. So, जो भी equation आपको दिया गया है, वो equation को simplify करो. If it is algebraic equation, obviously, then consider the lowest degree term and equate it to 0. That will give you tangent at origin if the curve passes through origin. Then we will check whether the curve intersect with coordinate axis, and we know it is easy how to find the point of intersection. That is, अगर x axis को वो कट करते हैं तो put y equal to 0. To find the intersection with y axis, put x equal to 0. If curve is symmetric about y equal to x or y equal to minus x, find the point of intersection of the curve with these lines, and also find the tangent at the point, because the tangent leads the curve. So if you consider the second rule, point of intersection, we have to check curve किस पॉइंट से पास हो रहा है. फर्स्ट ऑफ ऑल हम देखेंगे वो ओरिजिन पे हो रहा है क्या. अगर ओरिजिन पे हो रहा है तो हम tangent at origin find out करेंगे. If not, then we will check कि whether it intersect with coordinate axis. If it is passing with intersecting with coordinate axis, we can easily find the point of intersection. Also, we will find out the tangent. Also, if line y equal to x or minus x is given, the same procedure we have to repeat. These two are very simple in nature, symmetric and point of intersection. For every curve of Cartesian type, you can easily find out these two. The third one is a new concept for you, asymptotes. Now, what asymptote is? Asymptotes are tangents to curve at infinity. So at infinity, curve की जो tangents है उसको बोलते हैं asymptotes. So there are two types of asymptotes. One is asymptote parallel to coordinate axis. So if you are having an asymptote parallel to coordinate axis, the procedure is to find the equation of asymptote parallel to x-axis, equate the coefficient of highest degree term of x to 0. Similar case with the y-axis. So whenever we are equating the highest degree term of x to 0 in the equation, that will leads you to asymptote parallel to x-axis. To find the equation of asymptote parallel to y-axis, we have to equate the coefficient of highest degree term in y to 0. This first type of asymptote we will require very frequently. The second type of asymptote is called as oblique asymptotes. Asymptotes which are not parallel to coordinate axis are called as oblique asymptotes. So there are two different methods to find out these oblique asymptotes? The first method is, in first method, we will check, let y equal to mx plus c be the equation of asymptote. Then the point of intersection with the curve f of xy equal to 0 is given by f of x comma mx plus c equal to 0. That is, हम y की जगह mx plus c put करते हैं equation में. Equate to 0 the coefficient of two successive highest powers of x. So if the oblique asymptote is there, that is asymptote which is not parallel to coordinate axis, these asymptotes can be found by two methods. The first method, y equal to mx plus c. This method can be used if the point of intersection f of xy equal to 0 with the curve given by f of x comma mx plus c. Simplifying this, we equate the coefficient of two successive highest powers of x, and giving these equations, we solve them to determine the value of m and c. Replacing in the equation, we get the equation of oblique asymptote. Method 2, again let y equal to mx plus c be the asymptote. We will find out phi n of m by putting x equal to 1 and y equal to m in the highest degree term. Then similarly we'll calculate phi n minus m. Then we will solve phi n of m equal to 0 to determine the value of m. Then we will find out c by solving phi n minus 1m upon phi n dash of m. If the roots of m, जो हमने c step में find out किया, if these roots are equal, then we will find out c by the formula c square by 2 phi double dash of m plus c phi double dash of m plus phi n minus 2 of m equal to 0. By solving this, we will get the value of c. But very rarely we are going to use this method, because whatever the asymptotes standard we require, these are parallel to x-axis or y-axis, और oblique asymptote भी आता है तो आप method number 1 से easily find out कर सकते हो. Now the next rule is spatial point on the curve. Now this is very important. We have seen the spatial points earlier and here we require them. First we will find out such points on the curves by presence. जैसे कि अगर समझ के ले लो इक्वेशन में आपको मिल रहा है y square equal to 0. That means y equal to 0 2 times. So y आपका double, so 0 0 आपका double point है. So in this case, whenever we are finding double point, triple point है क्या, अगर है तो उसके टाइप क्या है, वो इस तरीके से इजीली आपको जिस तरीके से आइडेंटिफाई कर सकते हो तो कर लो, इजीली डिटेक्टेड होते हैं. If not, find dy by dx and the points where the tangents are parallel to either axis. तो dy by dx फाइंड आउट करके आपको टेंजेंट पॉइंट फाइंड आउट करना चाहिए जहां पर टेंजेंट पैरेलल टू एक्स एक्सिस और वाई एक्सिस होते हैं. फॉर एग्जांपल, सपोज dy by dx at p x1 y1 equal to 0 आता है, then the tangent p at p x1 y1 is parallel to x axis. If we get dy by dx at p x1 y1 equal to infinity, then the tangent at this point is parallel to y-axis. So to find the spatial points, we will first check by observation. If not, then we will find out the dy by dx and we will check if dy by dx equal to 0, then at that point tangent is parallel to x-axis. If it is equal to infinity, then it is parallel to y-axis. And the last, also find the point of inflection if any double point is there. अगर double point है तो check whether it is point of inflection or not. If not, then it's okay. But most of the time we require the double points which are cusp and node very frequently. Okay, so till this we have studied rule number 1 to 4. First rule is symmetric, second one is point of intersection, third one is asymptote, and fourth one is spatial point. In the next video we are going to learn rule number 5, Add important remarks and example based on this.